There comes a point so unimaginably distant from Earth that sunlight no longer feels familiar. Beyond the giant planets, beyond the comforting influence of our Sun, lies a region where the solar system gradually gives way to the vastness of the Milky Way. It is a place where darkness dominates, where temperatures approach absolute zero, and where no spacecraft was ever expected to survive. Yet one small explorer continues its lonely voyage. More than 4 decades after launch, Voyager 1 is still traveling through this remote frontier, quietly transmitting signals across billions of kilometers of empty space. Every message it sends is a reminder that humanity has reached farther into the universe than anyone once believed possible. When Voyager 1 left Earth in September 1977, its objectives were remarkably modest. Engineers expected it to spend only a few years investigating Jupiter and Saturn before its mission gradually came to an end. No one imagined it would become the most distant human-made object ever created, let alone the first spacecraft to enter interstellar space. Its incredible journey became possible because of an extraordinary alignment of the outer planets. Roughly once every 175 years, Jupiter, Saturn, Uranus, and Neptune line up in a way that allows a spacecraft to steal momentum from each world's gravity, accelerating toward the next destination while conserving precious fuel. NASA recognized this rare opportunity and designed the Voyager missions to take full advantage of it. Even during its earliest days, Voyager 1 was already exceeding expectations. Only a short time after launch, the spacecraft turned its cameras back toward home and captured an unforgettable view of Earth and the Moon together from deep space. From millions of kilometers away, our entire world appeared incredibly small against the endless darkness, offering one of humanity's earliest glimpses of itself from the outside. As Voyager approached Jupiter in 1979, scientists anticipated remarkable discoveries, but few expected the scale of what they were about to witness. The giant planet revealed itself as an incredibly active world dominated by powerful storms, immense radiation belts, and an intricate family of moons unlike anything previously explored. Among its greatest discoveries was a closer examination of the Great Red Spot. Long observed through telescopes on Earth, the enormous storm was finally seen in extraordinary detail. Larger than our own planet and raging continuously for centuries, it demonstrated the immense power of Jupiter's atmosphere. The surprises continued. Voyager detected a faint ring system surrounding Jupiter, proving that rings were not unique to Saturn. It also identified previously unknown moons, expanding our understanding of the giant planet's complex environment. Perhaps the most astonishing revelation came from Io. Instead of a frozen, inactive moon, Voyager observed towering volcanic eruptions blasting material hundreds of kilometers into space. It was the first direct evidence of active volcanism beyond Earth, transforming scientists' understanding of how distant worlds evolve. Europa presented an entirely different mystery. Beneath its smooth, fractured shell of ice appeared clues suggesting the presence of a vast liquid ocean hidden below the surface. That possibility fundamentally changed the search for extraterrestrial life, introducing the idea that habitable environments might exist beneath frozen crusts rather than only on planetary surfaces. After completing its investigation of Jupiter, Voyager continued toward Saturn, carrying with it the momentum gained from the giant planet's gravity. Upon arrival, Saturn proved to be far more intricate than astronomers had imagined. Its famous rings, once thought to consist of only a handful of broad bands, were revealed as countless delicate ringlets sculpted by gravity and the motion of nearby moons. Titan soon became the mission's primary scientific target. Wrapped in a dense orange atmosphere, Saturn's largest moon concealed its surface from visible light, yet Voyager's instruments revealed a fascinating chemical world dominated by nitrogen and methane. Scientists realized that methane there behaves much like water on Earth, forming clouds, rain, and possibly lakes, creating an environment unlike any other known in the solar system. Reaching Titan required a carefully planned flyby that permanently altered Voyager 1's course. Saturn's gravity redirected the spacecraft out of the plane where the planets orbit, ending any opportunity to continue toward Uranus or Neptune. Although that decision closed one chapter of exploration, it opened another far greater one. From that moment forward, Voyager 1 was no longer simply exploring planets. It was embarking on a journey toward the unknown, heading for the distant boundary where the sun's influence fades and interstellar space begins. A frontier no human-made object had ever crossed. As Voyager 1 left the familiar planets behind, its mission transformed into something no one had anticipated. The spectacular encounters with Jupiter and Saturn were over, but ahead lay an objective that had never been achieved before. The spacecraft was heading toward the invisible frontier separating our solar system from the immense expanse between the stars. For decades, astronomers believed this outer boundary would be difficult to identify. The Sun continuously releases a stream of charged particles known as the solar wind, creating an enormous protective bubble called the heliosphere. Scientists expected this bubble to fade gradually into interstellar space, with no clear dividing line between the two regions. Voyager 1 revealed a completely different reality. In August 2012, its instruments recorded a sudden and dramatic shift. Particles originating from the Sun rapidly declined, while energetic cosmic rays arriving from the galaxy increased almost immediately. At the same time, the surrounding magnetic environment changed in a way that could not be ignored. Rather than drifting through a slow transition, Voyager appeared to pass through a remarkably distinct boundary. In just a short period, it moved from a region dominated by the Sun into one controlled by the wider Milky Way. Humanity had officially placed its first spacecraft into interstellar space. The discovery forced scientists to rethink the shape of the solar system itself. Instead of expanding freely into the galaxy, the heliosphere exists under constant pressure from the interstellar medium surrounding it. Our Sun is not isolated in a vast empty void, it is moving through an active galactic environment that continually shapes the limits of its influence. Even more surprising was what Voyager encountered after crossing that frontier. Interstellar space is often imagined as completely empty, a silent vacuum stretching endlessly between the stars. But Voyager's measurements painted a far richer picture. The space between stellar systems contains an extremely thin mixture of charged particles, magnetic fields, and ionized gas that behaves in surprisingly complex ways. One of the spacecraft's most fascinating discoveries emerged years after entering interstellar space. Its instruments detected persistent plasma oscillations, subtle electromagnetic vibrations moving through the sparse ionized gas between the stars. When researchers converted those measurements into audible frequencies, they revealed a continuous, haunting tone unlike anything previously recorded. This was not sound in the everyday sense, since sound cannot travel through the vacuum of space. Instead, it represented the natural oscillations of interstellar plasma. By studying these waves, scientists could directly calculate the density of the material surrounding Voyager, providing the first-in-place measurements of the local interstellar medium. For the first time, humanity was not simply modeling the environment beyond the solar system. We were sampling it directly. These observations also showed that the interstellar magnetic field was stronger than many theoretical predictions had suggested. The surrounding galaxy exerts far greater pressure on the heliosphere than previously understood, continually compressing and shaping the Sun's enormous protective bubble. The implications were profound. The solar system is not floating through a featureless emptiness but traveling within a dynamic region influenced by ancient stellar explosions, magnetic fields, cosmic radiation, and vast clouds of interstellar material. Voyager's measurements even contributed to a better understanding of the local bubble, a gigantic cavity likely carved by multiple supernova explosions millions of years ago. Our solar system resides within this immense structure, whose properties affect how cosmic rays travel through our galactic neighborhood. Every transmission from Voyager continued to challenge assumptions. Instead of discovering emptiness, it revealed an environment filled with invisible structure, subtle forces, and physical processes operating across unimaginable distances. The farther the spacecraft traveled, the clearer one message became. The boundary beyond our solar system is not the end of anything. It is the beginning of an entirely new frontier, one where the influence of our Sun gives way to the vast and ever-changing environment of the Milky Way itself.